Exercise 176, page 444, question 4. Differentiate the function 2 over 3x plus 1 with respect to u. So what we need to do is differentiate the function with respect to x and then multiply that by the differential of x with respect to u. We need to recognize that 2 over is the inverse of 3x plus 1, so this equals d by dx of 2 times 3x plus 1 to the minus 1 multiplied by dx by du. And we need to use the chain rule to do this part of it. So what we do is we let v, say, equal the inner function, which is 3x plus 1. So dv by dx equals 3. Now what we do is we find d by dx of the function, we find d by dv of the function 2 times u to the minus v to the minus 1, because we've let v equal 3x plus 1, and then multiply that by dv by dx, which we found dv by dx is 3. So we have that this equals, the differential with respect to v of this is minus 2 v to the minus 2 times dv by dx, which is 3. And so this equals minus 2 times 3 is minus 6 over v squared, and v is 3x plus 1 all squared. So this we now put back into our implicit differential. So this will then become minus 6 over 3x plus 1 all squared times dx by du. So not very straightforward. Take your time, have a look at it again and see if you can see how it works. We're using the chain rule combined with this idea of implicit differentiation. Part B, we want to differentiate with respect to u. This function here, which is in terms of theta, so this is going to equal d by d theta of the function 3 sec 2 theta multiplied by d theta by du, which is what we want to differentiate with respect to. Luckily for us, this function inside the square bracket is in our standard differentials, our extended table. The differential of sec ax becomes a sec ax tan ax. And again, the explanation is on page 419 if you're interested. So a sec ax tan ax. So this becomes a, which is 2, times 3 is 6, sec 2 theta times the tangent of 2 theta times d theta by du. Part C, differentiate with respect to u this function here inside the square brackets. So again, we need to differentiate with respect to y. And if we think about how we can rewrite this, the 2 times y to the, it's the square root is a half, and it's the inverse, so it's minus a half. And then multiply that by dy by du. Now I'm sure you can use a table of standard differentials and come up with the answer in the textbook. It's going to involve a little bit of manipulation at the end to get the solution in the book.